And the next topic is effect of uniform and non-uniform amplitude distributions. Up to now, we have seen uniform amplitude distributions and non-uniform. What are the effects we will see? Okay, what are the effects we will see here? Okay, so in the synthesis of an antenna, for example, side lobe level ratio. For example, side lobe level ratio. What is meant by this side lobe level ratio? It is the magnitude of side lobe to the magnitude of major lobe. Okay, so for example, one customer asks, I want my side lobe level to 20 dB or 30 dB. The ratio of side lobe level to main lobe level SLR should be 30 dB. How to design that? How to design that? That is possible by using Dolph-Chebyshev polynomial. That is possible by using Dolph-Chebyshev polynomial. Side lobe level ratio. You can design the side lobe level ratio according to the requirements. Okay, by using Dolph-Chebyshev polynomial. Okay, so see here, it is often. So the two characteristics are using the improvement in characteristics determined by. So this CL Dolph is the professor who has invented this Dolph-Chebyshev polynomial. Okay, so according to him, the beam width between first nulls is specified. If we specify the beam width between first nulls, then the side lobe levels can be minimized. The current distribution to produce such a pattern is called as Dolph-Chebyshev distribution or Dolph-Chebyshev distribution. Okay, so he has given this Dolph-Chebyshev polynomial. Okay, so the antenna arrays based on Dolph-Chebyshev distribution are called as Dolph-Chebyshev arrays. Okay, so he has stated that if the optimum provided the distance between two successful arrays, elements D is less than lambda by 2. According to approach, it is practically very difficult to reduce the side lobe level without sacrificing the antenna performance in some other aspects such as beam width, gain, or directivity. Okay, so the 20 dB level is considered to be good, and SLR side lobe level is shown 30 to be excellent, but it is practically not difficult, very difficult to obtain 40 dB. Okay, so now let us see here. What are the Chebyshev polynomials? Let us discuss what are the Chebyshev polynomials. So the fundamentals of Chebyshev polynomials. So the Chebyshev polynomials with variable x is denoted with Tm of x. Okay, so the Chebyshev polynomial is given as Tm of x is equal to cos of m into, these are given by CL Dolph. Okay, cos x. This is for -1 less than x less than +1. Okay, let us consider this is expression again. The other expression for Dolph-Chebyshev polynomial has given as Tm of x is equal to cos h into m cos h inverse of x. This is for mod x greater than or equal to 1. Okay. So here the m is an integer constant with range from 0 to infinity. Okay, so the Dolph-Chebyshev polynomial for different values of m. Okay, let us take for let m is equal to 0. Let m is equal to 0. Now I am taking this expression a. Okay, substitute here. Substitute for m is equal to 0. The above expression a can be written as T0 of x is equal to, in the place of m, simply replace 0. T0 of x is equal to cos into here m I will write cos inverse of x. Here I am assuming let delta is equal to cos inverse of x. Okay, so therefore T0 of x is equal to cos m. In the place of cos inverse of x, I'm simply saying delta. Okay, so here T0 of x, here what is the value of m? M is equal to 0, that is equal to cos. Here m value is 0, so cos 0. Okay, so what is the value of cos 0? 1. So what is the value of T0 of x? T0 of x is equal to 1. T0 of x is equal to 1. Okay, so now let us go for m is equal to 2. Let us consider m is equal to 1. Okay, so how can I write that expression? For m is equal to T1 of x is equal to T1 of x is equal to cos, m value is 1 into cos inverse of x. Cos inverse, what you get? X. Therefore, what is the value of T1 of x? T1 of x is equal to x. In the previous case, what is the value of T0 of x? T0 of x is equal to 1. T1 of x is equal to x. Now let us take for m is equal to 2. Now let us take, okay, so T2 of x is equal to, what is the expression? Cos 2 into cos inverse of x. Cos inverse of x, I can write it as 2 delta. Okay, so T2 of x is equal to cos 2 delta. What is the formula for cos 2 theta, for example? It is 2 cos square theta minus 1. The same thing I will write here. So it is 2 cos square theta minus 1. Okay, so this is T2 of x. Okay, so cos x we are calling it as delta. So cos square delta, sorry, cos x we are calling it as x. Why it is cos x is calling it as x? What is the assumption you have made? Let delta is equal to cos x. Okay, so then delta is equal to cos x means cos delta is equal to x. Cos delta is equal to x. Therefore, in the cos delta is equal to x. Okay, so in the cos square means T2 of x. So can I replace this? 2x square minus 1. So this is the expression for T2 of x. This is the expression for T2 of x. Similarly, for m is equal to 3. Similarly, for m is equal to 3, what is the expression? T3 of x is equal to, what is the expression? T3 of x is equal to cos 3 delta. Okay, you know what is the formula for cos 3 theta? Cos 3 theta is equal to, what is the formula for the cos 3 theta? 4 cos cube theta minus 3 cos theta. This is the formula. Okay. So similarly, cos 3 delta. What is the formula? 4 cos cube delta minus 3 cos delta. Okay. So therefore, T3 of x is equal to 4 cos cube delta minus 3 cos delta. We know that what is the value of cos delta? Cos delta is equal to x. Therefore, T3 of x is equal to 4x cube minus 3x. T cube of x is equal to 4x cube minus 3x. Similarly, you can go for m is equal to 4. Okay, so what is the expression for T4 of x? It is cos 4 delta. Okay, cos 4 delta means, what is the expression for cos 4 delta? Cos 4 delta is equal to 2 cos square 2 delta minus 1. 2 cos square 2 delta minus 1. Okay, like that. For higher orders, the expression is for higher powers, you can write it as Tm plus 1 of x is equal to 2 into Tm of x minus Tm minus 1 of x. Tm of x minus Tm minus 1 of x. Okay. For example, if I want to calculate for 5, you can take like this. T4 plus 1 of x is equal to 2 into T4 of x minus T4 minus 1, it is T3 of x. Already you know what is the value of T4 of x. You know the value of T3 of x. Okay, so simply substitute that. What is the value of T4 of x? We have calculated the T4 of x is 8x power 4 minus 8x square plus 1 minus, what is the value of T cube of x? T3 of x. T3 of x is equal to 4x cube minus 3x. Yes. 4x cubed minus 3x. Like this, if we calculate it, substituted, we will get a different values. So see here, for m is equal to 0. What is the value of T0 of x? Is 1. For m is equal to 1. What is the value of T1 of x? It is x. For m is equal to 2. What is the value of T2 of x? T2 of x is equal to 2x square minus x. For m is equal to 3. T3 of x is equal to, its value is 4x cube minus 3x. For m is equal to 4. What is the value of T4 of x? This value is 8x power 4 minus 8x square plus 1. Similarly, for m is equal to 5, that is d5 of x is equal to 16x power 5 minus 20x cube plus 5x. Okay. So for m is equal to 6, d6 of x is equal to 32x power 6 minus 48x power 4 plus 18x square minus, similarly for m is equal to 7, d7 of x is equal to 64x power 7 minus 14x power 5 plus 56x cube minus 7x. Similarly for m is equal to 8, that is d8 of x is equal to 128x power 8 minus 256 x power 6 plus 160x power 4 minus 32 x square plus, like this we can calculate this Chebyshev polynomial. We can calculate this Chebyshev polynomials. Chebyshev polynomials. Okay, so the degree of the Chebyshev polynomial is same as the value of m. Okay, so the value of m can be either even or odd. Okay, so here the value of m may be either even number or odd number, anything. Okay, so the characteristics of Chebyshev polynomial for even and odd values of m are shown in the below figure. See here, from the Chebyshev polynomial, it can be seen that all the values will oscillate in between -1 and 1. In the region mod x less than 1, the mth order Chebyshev polynomial process m times. In the region mod x greater than 1, the Chebyshev polynomial goes on increasing without any control. So here, this is the diagram. So this is the Chebyshev polynomial for m is equal to 1, and it is the Chebyshev polynomial for m is equal to odd. Okay, so here what is saying that, so in the region mod x less than 1, okay, the Chebyshev polynomial process m times. So mod x less than 1 means here in between this. So beyond 1, the Chebyshev polynomial increases without any control. Beyond 1, between after -1 and +1, the Chebyshev polynomial increases without any control. Okay, so without any control. Okay. So all the polynomials are split in between -1 and 1. Okay, so this is the thing. Next, so from the above figure, from this figure, it is clear that the axis varied from an arbitrary point, say up to a specific value x naught, and varied back to a, then the polynomial Tm of x, traces a pattern which includes one major loop, many side loops, and the secondary minor loop of the same amplitude equal to unity, and the side loops are arising for x less than 1, and the main loop is extending far from the region x greater than 1. Okay, so the nulls of the Chebyshev polynomial are given by the roots of the nulls of the Chebyshev. The nulls of the Chebyshev polynomial are given by the roots of mth degree Chebyshev polynomial as follows. That is Tm of x is equal to cos m into cos inverse of x, that is equal to cos m delta, where cos delta is equal to x. The nulls can be given as cos m delta is equal to 0. Okay, so cos m delta is equal to 0 means m delta is equal to cos inverse of 0, or m delta is equal to 2k minus 1 pi by 2. Therefore, the delta is equal to 2k minus 1 pi by 2m, where k is equal to 1, 2, 3, so on. Okay, k is equal to 1, 2, this one. So these are the effects of uniform and non-uniform amplitude distribution. These are the effects of uniform and non-uniform distribution.